So we're back. Good afternoon. I'm with Mathilde and Laurent Bertineau from NERSC. As I promised, I will show you again how to access the practical exercises, the hands-on exercises. So let me share my screen with this. Yes, this is a good one. Okay. Okay. And I'll just show you, okay, the participant manual. Okay, so you should receive an email with a link to access the different tutorial videos and the participant manual and all the presentation from the different speakers. And in this participant manual, so if I navigate in the document, I can zoom in on the document. Okay, there is explanation on the document, a presentation of the speakers, tools and platform. Okay, so this is here. Practical environment. So you have the link here to access the Jupyter Hub environment for Siemens. You should receive an email with your username and password. So you can access then the Jupyter Siemens. It's like that. So now I can show you how it is look like. So share notebook, article. Okay. I close some windows. Okay. So here you are in the folder training article with the different folder corresponding to the different source type of products, kind of products, with in-situ product, physical model product, bio model product, wave model product, CIS product, and in-situ KEPLER product. In-situ KEPLER folder with a notebook on in-situ product. So when you log the first time, you will arrive on this page, on this environment. So it's very simple. If you want just to have a look to the different notebook, you can just navigate on the folder, say okay, and for example in the folder on physical model product, you will access to different other folder with data, docs, image, and output folder, and with the notebook. So with this extension, and you have just to double click. So you open the Jupyter notebook. And at the same time, or if you want to discover the notebook, you can do this. You can try to understand by your own. And if you need help to understand the Jupyter notebook, you need to go on the Jupyter, the YouTube platform of Siemens, and you will have access to the Jupyter tutorial videos for the Arctic Ocean available here. So just to choose the right one, physical model, double click, and then you have the video tutorial. So this is a video made by Simon Boitard from Noveltis. And Simon is explaining you in this video how to run the Jupyter Lab. Okay, there is a snapshot, and you can hear Simon explaining you how to run the notebook. So, and to run a notebook, it's very simple. A notebook, it's a mixture of text and codes, part of tests and codes, and in different cells, what we call cells. And you have just to run cell after cell, clicking here on this button. So you have just to click here. So you have to read the text part to understand the explanation about the data, the description of the model, etc. To have more info, there is some link to access the product user manual or the quality information document. What modules are required to launch the notebook? It's in the case you want to practice this Jupyter notebook on your own computer, you need to install Jupyter environment like Anaconda, and you have to install all these modules to be able to run this Jupyter notebook. But you can run the Jupyter directly on this platform. And then here we go. You launch. You can launch the first cell with codes, and when you have in between these brackets, when you have the stars, it means that the computer is running. And when you have a number, okay, the cell is finished. Okay. So, for example, I run some cell. I'm running some cell with you to show you. Okay, can define good pass. Okay, now, so I downloaded this file on my folder, and now I'm looking what is inside this notebook, this netcdf file, and I have information on the longitude, latitude, and different data parameters. Okay, and I go here. Okay, I have some info, some information about the institution. I can find all the coordinates. So okay. Okay, and now this is the first exercise. So I'm not going to make this notebook to make completely this notebook. I would like to show you a map, for example. If I can generate the map, yes. Here, for example, no. Okay. Okay. Oh, there is an error. Yes, because I didn't give the correct I guess the correct figure out name. Yes, I have to complete something somewhere, but I didn't read the text before to do this demo, but don't worry, I'm pretty sure that it works. So don't worry about that. So if you now I was running this Jupyter notebook on the platform, but on the public part. If you want to save all the modification, because what you can do on this kind of Jupyter notebook, on this kind of environment, is that you can change the codes. Okay, you can change some parameters, some boundaries for the map, for example, etc. So, and you can save all this modification on your own directory. So the best to do is, before to start running the notebook and make some modification, you need to copy this notebook on your home directory. And to do that, you have just to launch a terminal like this. You go back to your participant manual, and on your participant manual, you go there on this orange table, and you have all the command line to copy each folder. So if, for example, I want to copy the folder on in situ CIS product, sorry, I just take this line, copy and paste here. Okay. This is a demo effect. I like that. Don't worry. I know that it's working. Oh. There's perhaps a mistake on the sentence, but oh, data. Okay, it's working. So perhaps on these lines I have some perhaps a little mistake, but don't worry. For bio model product, it works. So now I have the folder here, this copy. So this is a copy, and I can use it on my own directory and make my own modification. So you see, it's very simple. I will check what is happened on this number 5, but don't worry, we will correct this soon, pretty soon. So that's it for me. And I think it's time to start the KEPLER KEPLER session. Just as a reminder, let me put this agenda, and I will ask Laurent and Mathilde to join me.
Yes, I was just checking the notebook.
I didn't.
Normally it should work.
No. Sometimes when you copy a line, you can have some space character and work. But yeah. I'm not afraid about that. It works. I know that.
Yeah.
Don't worry. So let's start the KEPLER session. Okay.
Mm-hmm.
Yes.
So,
thank you, Fabrice, for this impressive demonstration. It sure works better when you try it at home than when you are in public. So
exactly.
So we're happy to have 3 speakers from the KEPLER project. As I said before the lunch break, the KEPLER project is a more strategic, 10 years ahead strategic implementation project in which we will try to see how the new Copernicus missions and the ICE services will work together and improve the services. And I will stop talking now and give the hand to Nick Hughes, who will present the KEPLER project, who he is coordinating.
Okay, thank you. My name's Nick Hughes. I'm from the Norwegian Meteorological Institute in charge of the ICE service, and I'm the coordinator of the KEPLER project. I'm not seeing my slides here. Here we come. Perfect. Okay. So KEPLER, it's an acronym for Key Environmental Monitoring for Polar Latitudes and European Readiness. And today I'll just give you the overview and sort of show you where we're heading to as we move towards the final stages of the project. And my colleagues, Kel Crisgard and Carolina Gabbero, will give you some more details about some of the studies we've been doing within the project. So we're a 2.25-year Horizon 2020 Coordination Support Action project. We have 15 partners from 8 different European countries, and we're now approaching the final 4 months of the project, maybe with another 3 months added on due to some delays for COVID. And we're answering a call to develop a roadmap for a mature European capacity for monitoring the polar regions, particularly the Arctic, but we also cover the Antarctic as well, and mainly concentrating on the sea ice and environmental conditions. So we have, in our 15 partner team, we have strong contributions from the Copernicus marine and land monitoring services, and also looking a little bit into the climate monitoring and the atmospheric monitoring services. And the aim was to try and make some recommendations to bring the current services beyond their current state of the art and to increase the number of users. So the idea of this workshop was to meet some of the users and present some of the findings so far, make you aware of the project, and that you can approach us and provide us with your wishes and desires as to how you want to see Copernicus develop in future. So we based our project around 7 work packages, and we wanted to make sure that the users and stakeholders were put in the center in their providing the information needed to steer the studies later in the project, which investigate what different improvements can take place and what should be done in the future. So we had work package 1, which looked at the stakeholder requirements and covered a number of different sectors. We looked at the current state of the art in the Copernicus services for the polar regions in work package 2. We then identified what research and capacity gaps were currently present and what needed to be done to address those in work package 3. Work package 4 looked into improving sea ice mapping and forecasting capabilities. And then finally, in our final stages of the project, we're moving into work package 5, which is coming up with this end-to-end roadmap of how Copernicus should develop in the future. And then finally, on top of that, we've got dissemination, engagement program, work package, and the management and coordination. There are 3 projects in this call. It was an Earth observation space call, which were to address the future of Copernicus. The others didn't really have a polar component. They dealt with agricultural land use and forestry mapping. We were the only one which had this particularly a marine component. And in that, we're kind of acting in an advisory role to the defence and industry and space Directorate General of the European Commission, who are the ones who manage and run Copernicus. And we had some key questions we wanted to address, which were what is the current state of Copernicus information provision, particularly for the polar regions? What can we do to better serve the end users and stakeholders? And how can data from the high priority candidate missions, which are the Simmer, Crystal and Roselle, be synergized with the existing Sentinel satellite constellation to improve the information provision? To start off with, we looked at the user requirements. This was, it was central to our work to discover who needed what, where they felt needs needed to be addressed, and try and bring their concerns forward to the Commission and hopefully into the future. So we had 3 sub tasks within this, looking at the maritime and research sector. Another one which is more terrestrial based, looking at community based observing and societal needs, including those of indigenous peoples, particularly in the far north of Europe. And then a task looking at more the intermediate user needs. This is like the weather forecasting agencies and those looking at climate forecasts and what they needed in terms of information provision. What we found was that looking back at a large number of previous projects and their attempts to engage with the user community, the maritime sector needs have been remarkably stable over the past 10-15 years. Yet the repeated polling is not yet yielding the desired improvements to the information products. And that although there's a lot of talk about improved information products, when it comes to actually getting those to people at sea, and even in some of the remote areas on land, high latitude communications remains an issue. It's a big barrier barrier to accessibility. If you're going to put out services and products, you want to make sure that people are able to see them and interact with them. And with the increasing data volumes we're seeing from Copernicus, that's only getting worse. And overall, for both land and sea, there's a need for high spatial resolution information products with a timely, near real-time delivery, and in familiar data formats which the users can are capable of using. So going on beyond the net CDF, which is more of a forecast modeler data format. Work package 3, which Carolina will address in her presentation in a few minutes, is identifying the research and capacity gaps. This looked at the in situ observing systems. We've already seen some of the comments that we recognise there is a lack of in situ observations, particularly from the Arctic. But how those could be addressed by bringing in things like citizen science programs. We looked at new and novel in situ and airborne observation sensors and techniques. So this started to look at some of the ideas people have for high altitude pseudo satellites, use of drones in the Arctic, and then maritime equipment like gliders and underwater vehicles. And then some of the sensors, including those looking to sort of geochemical parameters. A large part of that work package was looking at the space-based capability. This was addressing the current satellite-based observing components, the Sentinels, all the different other missions which were available, and then looking into the future as to how the high priority candidate missions would augment that and provide improved capability for mapping. Particularly things like sea ice and providing that at the mapping of that in a reliable, robust way. Then finally, the main scientific part of the project was to try and quantify what the effect of some of these options for new sensors would bring. So this involved a technique called quantitative network design, where a forecast model was driven using both the available observations, but also estimates as to the future observation capability, and then assessing what the overall improvement was. And then we also had some other tasks looking at requirements for ground truth information and the effects of implementing different options. The key findings for the Earth observation capability was that there's more parameters, and I guess Carolina will go into these in more detail in her presentation. There's more parameters which could be derived from the current satellite sensors we have and could be incorporated into future Copernicus services. And there's also parameters which could then be acquired using these future missions, which have this great potential for improved monitoring of the polar regions. However, to support the Earth observations, we realise again there needs to be a lot more focus taken on ground truth, so validation and calibration of the information coming from the satellites, and there needs to be a broader dialogue between the European Polar Research and Monitoring Community and the Copernicus services, because at the moment we can see this is impacting the quality of polar products and services on offer. And so there was a number of recommendations on quality control and using the wider community to provide some independent assessment of what the services are producing. To help with that, given the Arctic and polar regions are expensive and difficult to access, we should make as much use as possible of citizen science projects. So making use of tourist vessels, which are increasingly heading up to the Arctic, but also indigenous communities on land who are monitoring their own local environment. And for that, we need to see something like the Copernicus in situ component, which is kind of a separate well, it's not really classed as a service. It's a separate body within the Copernicus framework, having more of a role to kind of steer that and take ownership with the interacting with the community. Work package 4 will be addressed by Keld, and he'll talk more about recommendations for improvements to sea ice mapping. This will cover requirements at the different spatial and temporal scales. You see at the diagram on the right, there's big variation between those needing very high spatial and temporal resolution data for making operational decisions such as ship navigation, going through to the sort of lower resolution products which are needed more for planning activities in advance, and also for determining standards and regulations for how the Arctic and the Antarctic are used sustainably. In that, we saw there's need for firmer harmonization of sea ice mapping products. And there needs to be, at the moment, there's a very complex landscape of climate product suppliers who are all providing either different parameters or many variations on the same parameter, particularly things like sea ice concentration. And those need to be sort of better coordinated and streamlined. And then feeding from those, going into the forecast modeling, there's a desire for higher spatial resolution and more study into the effect of data assimilation onto the overall forecast quality. So whether the forecasts are actually reliable or not, and for how long a period out in advance. Moving forward, we're going into the final phase of the project, and this is where we come to our end-to-end operational system roadmap. This is synthesizing all the requirements which have been gathered throughout the period of the project, and then the different analyses provided by the other work packages, and then trying to make some recommendations as to how we'd implement this into an end-to-end operational monitoring system. So this covers all components of the system, including the observations, both in situ and spaceborne. Should be designed to support the needs of both, or for different many different facets of activity in the polar regions, such as monitoring climate change, looking at waste pollution management, safe and efficient navigation, and shifting towards a lower carbon economy and less impact on the environment. And we should also try to suggest some strategies to close the gaps in our current modelling and forecasting capabilities, and ways to develop and sustain the observing system in the future beyond current. A lot of the observing capability is currently research project based. So that concludes my overview, and I'll hand over now to Keld and Carolina. You can find a lot more information in the Kepler deliverables, which are on the website kepler-polar.eu. You can also sign up to the mailing list to receive regular updates from us. And you can contact us either at the email kepler@met.no, and also via Twitter and on Facebook. So thank you for your attention, and I'll let you hear some more detail about the other components of the project.
Thank you, Nick, for this very interesting introduction to the Kepler project. I don't see any questions on the chat. So I recall that you can ask your questions in the chat, and we will answer, or the experts actually will answer the questions either at the end of their talk or later on directly in the chat. So I let the floor to Laurent maybe to introduce the next speaker.
The next speaker is Kjell, isn't it? And Kjell is a representative of the Danish ice services. And so he has a long expertise of voyages in the Arctic. And so his work package, the work package he will present, has gathered experts of remote sensing and ice services. So it's I'm looking forward to the presentation.
So do you hear me now?
Yes.
Okay, thank you so much. So yes, thank you, Laurent, for the introduction. Yes, my name is Chris Gard, and I'm a senior ice specialist with the Danish Meteorological Institute. So I've been working with sea ice and icebergs and the marine community for a couple of decades now. So that's basically my background for this. I'll follow up on Nick's presentation on the high-level aspects of the KEPLER program. So and dive a little bit more into the details. So you saw this diagram showing the organization of the project, and I'll dive into work package 4 on recommendations for improvements of sea ice monitoring and forecasts. So I'll take out some high-level aspects from that part of the project. I would also very much highlight that you all go to the project website, because all the details, all the reports are sitting here, and I can only cover the high-level aspects of work package 4 today. So that's my approach to this presentation. So, but I'll go through the 3 work packages here. So because basically work package 4 was divided into 3 subtasks. One dealing with the sea ice mapping for serving the maritime community. There was components working on essential climate variables, and there was a third group assessing the scope for improved forecasts. So and all the task reports from these 3 groups are all available on the website, so you can find all the details here. So, but I'll start in reverse order. So start with task 4.3, assessing the scope for sea ice forecast. And basically, the objectives of that work package is what is the current status of sea ice forecasting? Are there any gaps, and can we provide any recommendations? Basically, the focus is what's needed to provide more reliable and user-relevant forecast products. And there was a group taking care of this, of the 8 experts, basically dealing with the time scales from days to seasons for forecasting the products. So what did they find out? Actually, some of the gaps they identified was that there's a need for focusing more on spatial resolution. Many users need fairly high resolution products, or even on sub-kilometer scale or an hourly scale. And some user groups even need updates several times daily. Sometimes it's not easy to provide that. There can be technical reasons or scientific reasons for since that's not the case. Another aspect they pointed out is the forecast quality, especially the ability to describe uncertainty, but also to go one level further to how do we present the quality and the uncertainty related to forecasting. They also pointed out that there are missing CI parameters and properties, and that could be, for example, the compression of ice or retention of ice and strength of ice, etc. So there are many aspects that also have some impact for users operating in ice. And a very important point they pointed out was that there's definitely needed some coordination and dialogue between the different forecast producers, but also user groups and even intermediate users. So that's the 4 high-level points that the gap they identified. So overall, they have identified there is not fully overlap between what is produced and what is actually coming out to the user community. So the idea is to reduce that. So they came up with a list of recommendations. So I have listed some of them here that are much not found in the report. So, but basically it's focused around the forecast quality, but also to ability to allow calibration law, multi-year records covering several decades. Also the ability to work with ensemble forecasts to quantify the uncertainty. Include more parameters, but also to bridge the gaps in expectations between the various communities. So from the producer to the intermediate user, again to the end user. So some high-level points on what to say, the soft points, the collaboration part, to say, okay, how can we actually talk more to do things better? So they also pointed out that training activities, actually, like what we're doing today, is very important for the user communities. So some very important points from recommendation from for the Copernicus services. And that should be understood in the focused evolution of Copernicus services in the long term, because we have a portfolio of forecasting products that's in many ways are very, very good. So there's no need to throw that away, because there's lots of very solid ground to build on. So within the framework of the existing forecast, a lot can be done with the dialogue, with the training activities, and improving the different products within the existing systems. So, they're also recommending that we should improve access to sea ice observations, including sea ice observations in the forecast. And obviously, the need for short-range, high-resolution forecast was also mentioned. So there are lots of aspects here, but I'd also like to highlight that in the report there are numerous targeted ideas. So I can highly recommend that you all go to the report and go through these points. Let's go to task 4.2 on the essential climate variables. So again, the approach was to go through what is the status and requirements, what are the current status, but also they would like to do, the team would like to do a survey between the different producers of these essential climate variables, because in Europe there are actually 4: Siemens, EUMETSAT, 33S, and ESAT. So and again, there was a project team that worked with this, and they basically the focus with their work was parameters on weeks to months to look into that. So again, the gap analysis recommendations for best practices and roadmaps to what new products was suggested. So and what is an essential climate variable? Well, the sea ice is not just one. There's actually about 50. So it must be recognized that the sea ice is one out of many very important climate variables that needs to be considered. So that's they are all listed here, and you can see sea ice is just one out of many. So but the gaps the group identified was that sea ice needs to be recognized as a multivariable essential climate variable, because sea ice is not just sea ice, because it needs to be described by thickness, melt points, sleet, snow, etc. There are many sub-parameters that need to be addressed. So the group also pointed out that there's a need for coordination in Europe. So there are many producers of these parameters, but some coordination is definitely needed. Better access to satellite data, maybe more correct to say long-term access to satellite data, R&D and validation is also important. And they also noted that it's not all implemented all across Europe. So that's also an important point. So their recommendation, they are the same message. Well, we need to treat sea ice as a parameter that contains many sub-parameters, as I just pointed out. So we also need to find funds to develop the focus on each parameter. So they also pointed out that we need satellite vision continuity for monitoring the sea ice variables. So and especially there are many parameters that we don't know much about, and these need to be addressed too. So and again, coordination between the various major players in Europe is is important. Another aspect they pointed out is that we typically go back to the late 70s when we talk about sea ice records, but there are actually sitting sea ice satellite data in the archives going back even longer back, but we need to do some work to rescue those data because they can actually provide more data to include in our model in our observation. So, and again, they focus on modeling our observation for various aspects. So there's lots of recommendation for Copernicus services. So task 4.1, improvement of sea ice products. That's actually the one that I participated in. Again, the objectives was current status, review the CMEMS portfolio, identify gaps, and provide some recommendations. We were a team from each of the Nordic ice services in Norway, Sweden, Finland, and Denmark. And we have actually kind of a dual role because we are heavily using CMEMS data, especially from the Sentinel-1 and Sentinel-2 constellation, but also Copernicus contributing missions are also heavily used in the ice services. And we are providing some selected products to the CMEMS portal. Our typical scales we work on is hours to days for serving the marine community, especially shipping in ice-covered waters needs frequent updates. So that's basically driving our work. So some of the gaps that we have identified is that when going into the CMEMS product catalog, we need to focus more on ice product resolution. The question about resolution, that's an important question because in some communities, 1 kilometer resolution is considered as high resolution, but it doesn't work in our community because serving the marine community, we need to work on a scale from typically from 10 to 100 meters. There are issues about the product update frequency, timeliness, especially in dynamic regions. The product needs to be updated quickly to serve the marine community. We are in the ice service community. We are not using this NetCDF. We need vector formats in our community. There are several parameters that are not available in the ice products. For example, the ice thickness, or the states of development, the ice widgets. But overall, the products that's currently sitting in the Copernicus catalog for sea, they're not intended, they're not developed to support direct support of navigation. We also learned that found that there's some limited regional focus. We need higher resolutions in certain areas, and there's limited one coverage at mid-latitude, and that's from latitude 50 to 55 up to 70, where we don't have daily coverage of the Sentinel-1 constellation. And also at the North Pole, the Sentinel-1 constellation covers the Arctic Ocean south of 87 degrees north. So we don't. The satellite constellation does not cover the North Pole. So there are actually there's a limited use of the current CMEMS sea ice portfolio in the ice services. What is driving that? Yeah, we came up with a long list of recommendations. Actually, in the report, there's 25 recommendations. So, we need to work on a regional scale to pan-Arctic scale on a daily basis. We need to work on other formats. We need to focus on the industry needs and requirements. In some areas, we need to focus very much on the variability. So because they are simply just changing requirements. So basically we need to work in higher resolution, but also the accuracy of iceberg products. There is an iceberg product sitting in the product catalog, and it's actually produced by DMI, but we are not using the product that's sitting in the CMEMS catalog. because there are too many targets sitting in that product to reuse. So we cannot use it in the operational daily work. Not yet, but it has improved a lot over in recent years. So again, working with the users and take their needs and requirements, and also how things are evolving over time to put that into the future Copernicus services. So, and actually what is driving this? Consulting the marine community, we have learned that we are dealing with a changing ice. That's not a surprise, but we work with a longer sea ice season. We have changing operating conditions. We have sea ice and icebergs in our waters, and that should be combined with other parameters when navigating in these areas. So, and the mariners request scalable ice information, so for example, in vectorized format, satellite images on board, high resolution, and in very dynamic regions, they need very frequent updates. That means a very short delivery time, but also that products are updated sub-daily. So there are lots of needs and requirements that need to be addressed, and especially the satellite information that's going to be used must be targeted at that specific need. So we also working with the risk management board on ships. So we try to combine, see what can we actually get out of the satellites when they're combining, when the fact that there is sea ice and there is iceberg, and then combine that into a risk product. That's something that we are working with the other ice services, also those in North America, but also the industry to develop so the mariners get the right product, all based on European satellites. So, and then there's an important parameter, that's uncertainty. So in the bottom I have shown a photo. That's thick first-year ice in late summer, and that's very important for shipping to be informed about that particular type of ice. But we should bear in mind that there are many of the existing satellite products sitting in the Siemens catalog that doesn't capture this type of ice. So that's a very good reason to only use the SAR data, so we can actually capture that type of ice and bring it into our ice product. So and that's an important aspect to bear in mind. So reliability of the products that come out, and they can actually be used on the bridge of the ship. That's really important. So that was some of the user requirements that we're trying to bring back into a set of recommendations for future Siemens services. So I think that's all what I have. So I'll stop here and again refer to the website that has all the information, and that has here a nice small photo of Joe Island in Narrow Strait. Thanks very much.
Thank you, Kjell. I see there's many more questions on the chat now than before. I counted 4 or 5 questions and 1 comment. So how do you proceed? Will you present the questions, Mercator?
Okay, I can put first question by someone in the audience, Fabrice Messal from Mercator. Is the information about the forecast uncertainty accessible to users, like a confidence indicator?
Yes, in a way it is, but for example, from the DMI side, we are not providing forecast information. So along with that, we are not providing forecast on uncertainty, but it's a parameter that the marine community actually would very much like to have, because when they get a product out, they also like to learn about what is, how can we trust this product? Is it reliable, or should we put add some level of uncertainty when we're using it? So it's kind of an answer in between.
Yeah, on the same line, so in the present forecast products, there is, say, a number for the forecast uncertainty, 1 number for each, say, forecast range, but there's not enough data to give, say, much more information than that to account that the forecast uncertainty may depend on where and when people are. So you have ideas on how this could be presented in a more user-friendly way,
There's not a short answer to that, so I think we should take that offline.
Yeah.
So, I see another question on my screen here. Expecting more iceberg in a warmer Arctic, and to be honest, we don't know because we don't have a long record of iceberg observations. We should bear in mind that the Sentinel-1 constellation was launched in 2014, and the second satellite in 2016. So we only have a few years of satellite records, and we're still developing the algorithms to detect targets, but also to filter out false targets. That could be noise, it could be shore artifacts, but it's also ships. We don't have that in place yet, so the actual number is it's not really known. So, and I don't really think that the number of icebergs will be reflected on the whole story, because we should bear in mind that if a big iceberg breaks into 20 pieces, we have 20 icebergs, but it's still the same amount of glacial ice. So it's we need to bring in the volume aspects in these discussions before we don't have the answer at the moment.
Yeah, thanks. We have a question from Mr. or Mrs. E. So.
Yes. Also, about any plans or actions to address the gap between the coverage from one region to the other, because seems there are more data around Greenland, Svalbard, and less in some other regions. Are you aware of some?
We have a very strong and established relationship to North America, USA, Canada, but also to Russia. So that could be considered also to be brought into a Copernicus context in the future, that we actually include more data from North America, but also from Russia in the high resolution CI files that we actually have.
That was an answer by Nick. Yeah.
Yeah. So yes, but all the data that's produced by the government ice services around the globe, they're actually sitting on this ice portal that's on the screen right now. So I think the future is to see how can we actually bring this further and bring it into a Copernicus context.
Yeah.
So we get the Arctic coverage, and we get the frequent updates, so that's coming into Copernicus as a product.
Yeah, and along the line of the format of the data, there was a comment by Cecilia Vetre saying that the GeoTIFF data are now being accessible through Siemens. So it seems that
I have noted that. Yes, I have noted that the Sentinel-1 images are now coming in GeoTIFF into Siemens, which I think is a step forward, but it's still not an exchange format for the ice services. We're working with vectorized data forms, so we're describing everything with points, lines, and polygons. And that's been done all over the globe among ice services. So, but we have already also noted that Siemens are providing some vectorized products. It's still in the very small beginning, but from our point of view, we're on the right track.
You just noted there's shapefile formats, which was good.
Yes,
work.
Yeah, the shapefiles I think were launched back in July, and I also noted that more shapefiles also dealing with sea ice will be coming in the next updates.
So that would be a workable solution if there is a pan-Arctic ice chart, would it be?
If yes, the short answer is yes. So I think the trick is how do we combine all the shapefiles that we have sitting around the globe into one product that could go into sea.
Yes. Brings me to another question by, I think it was earlier by E, how about the timeliness of the data. I guess one of the technical problems would be how to join data if they are produced at different times and different.
There are several steps in that, because we need to get the data from the satellite. So we need to have them to the ground, have them processed. and distributed to the ice services. Currently, many parameters are derived manually, but we would like gradually to implement automated or semi-automated methodology to work with the data, because in certain areas it's very critical for the mariner that they get updated data. So as a rule of thumb, the ice moves at about 1 kilometer per hour. So every hour you get data late, it's actually hampering your product. So there was another question concerning additional ice parameters. So there are many products sitting on the CMEMS website that's dealing with the ice concentration, but we also need the ice thickness, and for certain group of mariners, they also need the flow size, but also other parameters like ice drift in high resolution, sea ice ridging, but also compression of sea ice. That's important parameters for the marine community, and they're simply not available at the moment, not in the necessary resolution either.
So you see that some of these parameters will are likely to progress in the future with the new missions, and some others are like internal properties of the ice that are and will remain always inaccessible.
Yes.
So yeah, we'll come back to that with Carolina's presentation, I believe.
Yes, Laurent, I'll let you introduce the next presentation.
Yes.
Thank you. Thank you very much.
Thank you, Kel.
Okay, you're welcome.
So the next presenter is Carolina Gabarro, and she's a remote sensing expert from the Barcelona Expert Center in Remote Sensing, and she's leading the work package 3. And so it's a pleasure for me to introduce you.
Carolina? Yes, your microphone is muted.
Now I think you can hear me. Okay, great. Sorry, I couldn't find it. Hi, I'm going to present. I'm Carolina Gabarro from the Barcelona Express Center and Institute of Marine Science in Barcelona. And I'm going to present Work Package 3, and in particular, the research gaps on a space-based monitoring. The objective is to assess and do a status and a review of improvements which could be assessed on the remote sensing monitoring for the Copernicus program. I will present mainly work package or task 3.3, and we were more than 10 people. You can see we were 13 people from 10 different institutes from Europe, and it was the work I will present was done from all of us. So it was a large work, but we managed to achieve what we were looking for. I'm not going to present KEPLER because it was done by Nick. And this is the index of the presentation that follows the sections of the report. First, we wanted to do a state-of-the-art of the remote sensing parameters, polar parameters for sure. Then we identified the gaps that was in Copernicus service on relation of the remote sensing products. Then we assess or we analyze the parameters which could be provided by the future missions, and I'll put special emphasis on the HPCMs. Then I'll talk about the synergies. We will review the data simulation in Copernicus models and then provide a list of gaps and recommendations. First of all, we wanted to do this state-of-the-art to see where we were. For that, we reviewed more than 10 parameters, and for each of the parameter, we analyzed the sensors and technologies, and also the retrieval methods for each of the parameters. Then we assess the spatial resolution, temporal resolution, and latency. We also look for the validation strategies for each of the parameters, the error sources and uncertainties, and also we we added the gaps that we observed, or the known limitations for each parameters. The parameters for sea ice was sea ice concentration and thickness, sea ice drift and deformation, tape and age, snow surface temperature, and melt points. For land, it was a snow cover, snow water equivalent, snow melt, snow depth, snow avalanches, lake ice, and permafrost. For ocean, we assess the biochemical components, light, salinity, temperature, winds, and currents. So we did this analysis for each of the commented parameters. Once we had the state of the art, we look at which of those remote sensing parameters were served in Copernicus. And we've realized that 14 parameters were not currently being served in Copernicus, while the parameters were mature enough, and they are being served in universities or research centers' web pages. So this is a clear recommendation for the future evolution of Copernicus to add these parameters, which are sea ice age, melt point fraction, sea ice albedo and leads for sea ice, lake ice duration and thickness, snow melt and snow depth, snow avalanches, permafrost, and inland chlorophyll, and for ocean, surface current, surface stress, wave spectrum, and albedo, and ocean albedo. Then we wanted to see which parameters and with which quality we will have with the future missions. Of course, we couldn't review all the future missions possible available, so we focus especially on the high priority Copernicus missions with the 3 polar ones, this Crystal, Simar, and Rosal, and we also add some information of other missions that we are aware. We identified the different improvements with respect to what we have, and also possible synergies between them. First, I would like to show you this figure, which is, I think, is quite clear. The Polar Expert Group is a group, a European group that that provided in 2017 a report defining the priorities, the parameters which are prioritized to advance or to better monitor the polar regions. And they divide the parameters by floating ice, glacier and ice caps, ice sheets, and snow. And they specifically define which were the parameters which should be improved. So you can see that with the 3 HPCM satellites, Simar, Crystal, and Rosal, we cover all the best priority or the most priority parameters. Each sensor can cover different parameters. Now I'm going to explain each of the polar HPCM missions. I'll start with SIMA. SIMA comes from Copernicus Imaging Microwave Radiometer. The payload is a multi-frequency passive radiometer, and in fact is the continuity of AMSAR E and 2 and SMOS. Here, this figure shows the different bands that the SIMA will have, L, C, X, Q, and Ka bands. And you can see here the footprint size. So you can see that the L band from SIMA will have a worse resolution or larger footprint than SMOS, but the other bands, the resolution that is the blue is the footprint, yellow is the footprint of SIMA, is much better than the other passive microwaves. This is thanks to the big reflector that we'll have, that will be 7 meters, diameter of 7 meters large. SIMAR, the first, will serve for support maritime operations and also for climate change. And the first objective is to measure sea ice concentration and sea ice extent with a good temporal resolution and also spatial resolution. The second objective is sea surface temperature, and other objectives are on land snow extent, water equivalent, lake extent, and thickness. For sea ice, it will permit to measure sea ice thickness only when the thickness is thin, thanks to the L band. Snow depth on ice, which is really important, sea ice drift, sea ice, ice surface temperature, ice tape and age, and sea surface salinity and winds. We move to crystal. Crystal comes from Copernicus, polar ice, and snow topography altimeter. The payload of this mission is a synthetic aperture radar altimeter operating at 2 bands at the same time, QU band and KA band. This is a continuity of cryosat mission and will give support to maritime operations and also for climate change. Thanks to the 2 bands, you can see this figure, thanks to the 2 bands, it will be possible to assess the snow depth, which is really important to assess the ice thickness or to compute to derive the ice thickness from the freeboard measurement from the altimeter. So this is one of the main reasons for having 2 bands. And the way the radar altimeter works is to emitting a signal and then listening the scattering, and this way it can measure the ice thickness, the elevation of the ice with respect to the ocean. It can also compute the surface elevation, and the main objective of crystal is to measure sea ice thickness, but sea ice thickness of thick ice, only the quality of the crystal sea ice thickness is very good, only for thicker ice than 1 meter. So as said, CIMAR would be complement in this sea ice thickness measurement with respect to crystal, and it will also measure snow depth on sea ice. The second objective is surface elevation, which is very important to monitor Atlantic and Greenland ice sheets. Other objective is land surface elevation and permafrost, iceberg detections, and for ocean sea level. The third HPCM mission is RUSEL, Radar Observing System for Europe at L-band. The payload is a synthetic aperture radar at 1.2 gigahertz, that is also the L-band, and can it's important to know that at this band, this low frequency band, low microwave, the penetration is larger than working at higher bands. This is why this information will provide additional information to that we get from Sentinel-1 radar mission, which works at C-band. This mission could contribute to monitor the ice sheets and ice caps. However, the main objective is land cover and tape, landslides, floods, earthquakes. It's not specifically for polar, but for polar it can bring a lot of important information as a snow water equivalent, snow avalanches, lake ice, and extent, thickness, permafrost, and other properties. And for sea ice, it can measure the sea ice concentration and ice age, sea ice drift and deformation, and icebergs occurrence. At the end, we conclude that the HPCM has a great potential for improving the monitoring of the polar regions, and that would be especially good if we have the three of them missions flying at the same time, so we can combine data from one or the other. The fourth section was analyzing the current and potential synergies. We evaluate what we have. We call synergies when we talk about combining information from different type of sensors, satellites, to improve the parameter. And we evaluated the current and the potential synergies that we could do with the current or the future missions. And we realized that 18 potential synergies were already published in scientific literatures, and from these 18, only 4 are currently in Copernicus. So that is a clear recommendation to promote the production and distribution of these products resulting from synergies. In fact, we did this table from here. You can see that we are talking about passive microwave radiometer, radar altimeter, type of sensors, infrared sensor, optical sensors, and SAM. And we are combining in this table, the combination we are talking about, for example, combining passive microwave radiometer and radar altimeter. We have lake ice. For combining, we have also sea ice thickness in the complete spectrum of thickness, because we have the thin ice plus the thick ice. We can also determine ice tape, snow depth, and the red colors means that is already currently being served you can see that we identified many combination of sensors to improve our product, which are not being served in Copernicus. So this was a clear recommendation to Copernicus. Also, we analyzed the data assimilation methods and how could it be improved in Copernicus. So we analyzed the status quo of this and review the capabilities. We observed that several observations are routinely assimilated, remote sensing observations I'm talking. The parameters which are being assimilated with several limitations is the sea surface temperature from infrared, the sea ice thickness, ice drift, and chlorophyll. Some parameters are assimilated with medium level of limitations, like the sea ice concentration, and some are just being assimilated successfully as sea surface height and sea surface temperature from passive microwave radiometer. We realized that there is no assimilation of satellite data on any of the models from Land and Climate Change Service at the moment. And we also thought about possible parameters which could be assimilated in the models serving Copernicus. And we did 3 classifications, which parameters could be more or less easy to assimilate, let's say in short time, which were in midterm and which were in long term. So for short term, we identified that sea surface salinity and wave height could be assimilated. For midterm, sea ice drift, snow cover on land, permafrost, and ocean color parameters. And for long term, is sea ice surface temperature, melt ponds, rivers, soil moisture, and well, a few more. We also investigate the possibility of doing a simulation methodology, assimilating information at lower processing levels. When we mean lower processing levels, mean not assimilating a complete map, a product, level 3 product, a complete map of a parameter, but for example, level 2 product, that means swath or track of the satellite. We also investigate the possibility of assimilating level 1 observations. Level 1 is the brightness temperature and not sea ice thickness, for example, or not sea ice concentration, but assimilating lower level or backscatter, depending on the sensor. And we also identified that a co-design of the operators should be necessary to work together, people working on data simulation with remote sensing community. Then we did a complete list of gaps and recommendations for the improvement on the polar monitoring. We divided these recommendations between general land application, sea ice, and ocean applications. We also put a level of priority, also level of effort to achieve these improvements, and also the impact, the degree of impact to the users, which would represent these improvements. And here is a very general table of what we concluded. For general, for example, we said that it's important to have more in-situ observations, mainly for validating, well, in other issues, this is very important for validating the remote sensing data. We also need to reduce the polar observations hole and, well, some other. For land monitoring, we found that snow cover and snow avalanche monitoring is really important, among others. Snow depth on sea ice is really also an important point that we should solve. Also, sea ice concentration and sea ice thickness should be improved, especially during summer. And also sea surface salinity, wind speed, and biochemical compounds. Well, this is all. The report is a very long report, 180 pages, but I think, well, it's quite complete. In case you would like to read some parts, specific parts, you can find it here. You have the link to the report. And if you have any question or you want to contact me, here you have my email. Thank you very much.
Thank you, Carolina. The questions are starting to flow. So
Yes.
Publish this one. There's been a question from Edson about the plans for developing chlorophyll products for case 2 waters, the coastal waters, based on regional algorithms.
I don't know, maybe there are some plans, but not for Copernicus, to my knowledge. Maybe some universities or research centers, they are trying to do so with a Sentinel-3 satellite.
It's also my impression that the focus is so far on, say, case 1 waters, but the case 2 algorithms are very much tailored to one local area.
Exactly.
And then treating all of the Arctic shelves with only one algorithm would be very ambitious, I think. Then there's been a question from Fabrice himself. Are the studies showing improvement of assimilating lower processing level data? And
well, that is interesting. ECMWF started working on that, and they are assimilating the brightness temperature of osmosis of land, not assimilating soil moisture, which is the level 2 product, but assimilating the brightness temperature. And I think it has worked very well, even though it requires a lot of work on the development and the assimilation methodology. What we did in the Copernicus was just to put the question and think on how could it be assessed. Let's say go a step forward on the assimilation, but we have not been working on that.
I can add to that the demonstration in the weather community has been done for a long time, and it's used operationally. And in the case of the sea ice parameters, it would make sense to assimilate brightness temperature instead of ice concentration or ice thickness. But it's true that on the technical side, talking myself as someone who's doing data simulation, including these advanced operational observation operators would make, say, the assimilation code much more complex than what it is today. So it's there has to be a balance between the gains and the complexity.
Yes, we also have another question by Fabrice. Are the drones data and are they available? Do you have any information about?
I have no information on that. I know that they are trying to fly it. I think in Mosaic they did some tests with drones during Mosaic campaign, but I don't know which is the status of this.
I guess the use on land is much more widespread than on sea ice. You have less risk of losing the drone.
For sure. And maybe I missed the information, but what is the time frame for the expected launch of the crystal steamer?
Sorry, maybe I forgot to tell it. The plan is around 2025 to 2026. So 5 years from now, but this might be delayed. I don't know if they are on time.
Okay, thank you. I don't know if there are any other questions on the chat. Or...
I've seen people starting to type a question.
It's very frustrating to see someone typing and nothing appearing.
Yeah, it's an answer from Nick about the use of drones by Norse. So this, I think it is the branch of Norse in Tromsø or in northern Norway that's been flying drones across the Fram Strait.
That's true. In fact, the partners from Norse was on Work Package 3.2 on the assessment of future instruments for monitoring the Arctic, and they were part of this.
Yeah, and the crossing is about 500 or to 1,000 kilometers, I guess. So it's a very impressive flight, I would say. And question from Fabrice about the data from Mosaic. it's not automatic that the mosaic data will be published. So it will follow a route. If I'm correct, that if the data will be needs to be used by PhD students, then the PhD students will publish before, and so that's those of us who are very eager to get to use data as soon as we can will need to brace ourselves with a bit of patience.
Yeah, I think they will publish the data in 1 year or 2 years from finishing the campaign, and it will be published in a German webpage. So data server.
Yes,
Question by Sarah about crew.
Yeah, could be similar to Crystal. Yeah, we have Cryosat. Cryosat is the mission, the current mission, similar to Crystal. Crystal has been advanced for sure.
I can complement
was
that.
launched 10 or 12 years ago.
Yeah. So there's another Sarah Fleury who's leading a group in Toulouse, Lagos, and which Cryosat only has one of the bands of Crystal. Yeah. It has the K band, not the Q band. So no, the Q band, not the K band. Sorry, I got confused. And the Altica altimeter has on the opposite the K band, not the Q band. So the Lagos has a product demonstration period when the two satellites are available, and well, if you disregard some of the fact that the two satellites are not flying in tandem or collocated, then there are maps of snow depth derived from these two altimeters, and it's available on the Lagos website. Yes.
Yeah. Any other question? No. So maybe thank you very much, Carolina.
You're welcome.
Very interesting presentation, and maybe we can move on to the next presentation, which is about the training material that is available within this session. So as we mentioned this morning, the idea is to present the training material that was prepared for the Siemens workshop, but which has direct link with this KEPLER project. And just let me see. So okay, I don't know if sorry. First slide is for me, so I will present it, and then we will move on to the next part with Paz. So the first Jupyter notebook that is linked with KEPLER is the one about the sea ice observation product, satellite observation. And so for those who are not here this morning, these exercises deal with how to handle the NetCDF products with the Jupyter notebook. So reading, plotting the data, and you will see how to map the sea ice fraction from different products, from METNO and DMI, and also how to compute monthly means of the products and compare them with the physical model outputs, and analyze the seasonal evolution of the sea ice fraction. So I'll leave the floor to Paz, who will present the in situ notebooks. So Paz?
Yes, thank you. Well, this notebook that you can see here, they have been prepared for the Arctic workshop, so I already presented this morning, but some of them have been found interesting for the KEPLER project, like the one dedicated to the profilers. So you will find in the header like a tag with the logo of KEPLER. So I suggest you to pay attention to this one especially. Although I will encourage you to run all of them for sure to get to know better the data that the in situ thematic assembly center is providing for for the Arctic region in particular. And there is another one that doesn't appear in here, where we basically try to map the East Greenland current using the network of platform that is serving data for the in situ Arctic region. So please have a look also at this one because I think it's quite interesting. And that would be all. Yes.
Thank you, Paz.
Welcome.
Yes, here okay. So Vincent from Novelties, is he here? Yeah, we're just switching the presenters. Vincent is not here. I can. Yes, I see him. Great. Hi, Vincent. So Vincent from Novelties also the GIS training material that we have prepared for this session.
Okay, so I presented it this morning. So I'm not. I don't know if I'm going to do the full presentation, Mathilde. Okay. So we created a training based on GIS. So we're using QGIS, and this training is really about how to handle CMEMS data coming in NetCDF format, and how to present it in how to map it actually in a tool like a QGIS. So there's a training available. If you have any questions, you can ask me.
Okay. So thank you. It was brief. Okay, so again, all the material is available for the digital notebook. Everything is available on the Jupyter Hub, and you will receive in the afternoon, if it's not already the case, the credentials to access the digital notebooks. And for the GIS training, there are videos that are available on the Siemens YouTube channel, and you will receive the link also to access the videos and the document that goes with the videos to see which data were used for the training. So I don't know, Laurent, maybe you want to add something?
No, it's clear. So for the people who were present this morning, you had all the presentation about the practical exercises already done. As Mathilde said, you can access to all these materials through the thanks to the participant manual and with all the links. Now to continue and for this the end of this KEPLER session, and because we saw that results on this comment on the presentation of Keld, we need to improve some training activities around CIS data, CIS product for the CIS user community. We would like to propose you a short survey to end this session, and perhaps if we have just 1 or 2 minutes to discuss after that about the results with Nick and Laurent. So I will. Yes, thank you, Vincent. So we have just 6 questions about your needs about CIS data, and what would you expect in terms of training around this data in the future. So I'd like to answer this survey. So the first question is this one. What part of the Copernicus Marine Service and the CI's products should be improved to enhance your use of the service? So you can answer several proposal. So higher geographical resolution, higher temporal resolution, more API to access products available in different data formats, simplify the overview, direct access of the CI's products available, access to information on the product quality, improved scientific quality. So next question. To process and visualize CI's data, which kind of interface do you prefer? Command line interface with languages like Python, Fortran, C, or graphical user interface like Snap, Sentinel Earth Observation, browser, GIS, etc., or both. Today we try to provide you hands-on exercise on the both interface. About CI's file formats, which formats are you using the most? You can choosing 2 maximum. So you have NetCDF, GRIB or GRIB2, CSV, JSON, GeoTIFF, OpenDataBinary, KML, shapefiles, not in the list. I think I have to answer something, because otherwise you couldn't see the results. Or perhaps, Vincent, can you show the results at the end? If you hear me, can you answer? Okay. Question 4, the use of which language or tool do you wish to improve to use CI's data? So perhaps you want to improve your skills in Python or in C, in Java, Fortran, MATLAB, QGIS, NCView, Panoply, IDEAL, NCO, CDO, none of these. So thanks to your answer, we will be able to design future training on CI's product. So it's very important if you can collect your question. Ah, thank you. But I think there is other question. Can I share the other questions, Vincent, first? And we will see the results after. Thank you. Can you go back on the survey or not? Okay, it's not possible. So I think I have the other question.
And many people did complete all the questions until the end, so
okay.
It was not cheating. It was okay.
Okay, so perfect.
You were just much faster than you were.
So please, Vincent, can you? Yeah, okay, thank you. So, oh, okay. It's not a clear results of one on the other, but okay. High resolution, higher graphical resolution, higher temporal resolution and different data formats, access to information on the product quality. Okay. So all these answers were relevant.
Otherwise, we would not have asked in the first place.
Sorry?
Otherwise, we would never have asked first. Yeah.
Okay, this is the same for this one. So yes, it's I mean, it's not a big surprise to have this kind of answer, to have around 20% using both command line interface and graphical user interface. It's easier to make computation on command line interface with your own codes, and then after if you want to visualize the results or compare data, it's more easy or friendly on the graphical user interface. So, okay. About CIS5 format, which formats are you using the most? Okay, NetCDF, okay, DOTIFF, shapefiles. So that's why, yes, we have a lot of people using graphical user interface like perhaps a GIS tool to visualize shapefiles data.
There's two people who use other formats that are not on the list. That's worth noting.
And and we will.
Could you two who have selected are not in the list, could you please note them in the chat so that we are aware of them?
Please. Good idea. Good idea. Good idea. So the user on which language or tool do you wish to improve? Oh, perfect. Okay. Python, QGIS. So, okay, we will continue to provide this kind of exercise on this language and tool. Good news.
Only 5 for MATLAB.
Yes. Which topics would you like to be addressed during a practical session? Okay. Identification, validation, computation and visualization of indicators to compare against other data. Okay, comparison of data and building monitoring indicators. Okay, thanks to that, we will have a good idea of what to propose next time as exercise. Good. Thank you for your answer. And finally, with which other data product would you like to combine CIS data during a practical session? So, marine in situ products, marine physical products, and a mix of other kind of products. Okay, good. So it's very interesting to have these results. I'm pretty sure that we will use this to build the next training workshop for next year. We will try to make something with KEPLER during the next Arctic Summit next year. We hope we will be able to propose you some exercises or training session on CIS data. It was a long training workshop. Mathilde, you look tired. This is the end. I think it's already the night in Norway. Laurent, no, the sun is.
We had the sunset to the south. Yeah.
Yeah, so that on in your room. Okay, thank you very much to all the speakers and the trainers for this session to prepare all the presentation. Thank you, Mathilde, for your moderation. Thank you, Laurent, also for your involvement and your help to build this workshop. Thank you to all the Kepler team with Nick, Keld, and Carolina for this special session. I hope you enjoy your training workshop, and stay connected to your email. You will receive just after that the email with the password and the login to access the Jupyter Notebook exercises and all the information. Goodbye, everybody. Have a nice evening, and thank you again to the moderators and Vincent.
Yeah, see you in 2 weeks for the debriefing session on the exercises.
Exactly.
And all the questions and answers. So
yes.
On the 16th of December. Thank you very much to everyone.
Bye.
Bye, everyone.
Bye-bye.